Hello, it's Keith here, and this is lesson 11 of the SuckHunt series of my ZX programming tutorials, and we're on the Amstrad CPC again. We're going to be looking at more Amstrad CPC code. This time, hopefully it's going to be a bit shorter. Last one went on a long time. This time today, we're going to be looking at the introduction. You can see it over on the right here. It'll start up in just a second. This is the silly Operation Wolf parody. I believe Operation Wolf is actually ripping off the Commando movie, but anyway, that's what we're doing. This thing you can see here going away. So we're going to be looking at the code that does that, and also the code that handles the palette effects. There's various palette things that the game does. Firstly, the fade in and fade out there, and also the 3D effect, which I can just show you here. If I just press the C option here, you can see there are 3 possible palettes that the game can be played with, and this is depending on which kind of 3D glasses you're wearing. So there's a few little paletty things going on there. We'll be looking at that, and also some other interesting bits of the code. As I would say, you can get the source code from my website, you can get the game from my website as well, and you're welcome to take the game apart and rewrite it, making it more amazing, and then sell it for millions of pounds or dollars if you're in America. I don't care, you're welcome to do whatever you can with it, just have some fun with it. Anyway, let's go to the source code, let's take a look. Okay, so here's the start of the game. We'll just quickly go through some of the initialization because I think it's quite interesting possibly. So the game starts very low in memory because I'm using an awful lot of memory for this game, and we're just using the firmware here at the very start just to reset the screen and things. Easier to do it while the firmware is available to us before we start doing crazy things like overwriting the interrupt handler here. We're putting our own interrupt handler in here. I did discuss that last time. And then we're clearing the game memory, setting it all to 0. It's best to have 0 areas of memory because you might think they're 0 and they might usually be 0, but maybe they're not one time, and maybe your game then crashes and you end up with complaints. You know, if you're selling a game or something, best to make sure that the game memory is always starting from a consistent situation so you have less debugging to do. We're setting up our defaults here for the game parameters here, resetting the sound, and then what we're doing here is we're backing up some bytes of the code, and these are bytes that are modified with self-modifying code in 2D mode, and so by backing up what's currently there, we can reset it when we need to switch it back on later if we decide to switch back to 3D mode. And this is a good idea because the alternative to this would be to have 2 different modifying routines, one with the bytes to poke in for 3D mode and one with the bytes to poke in for 2D mode, and that's tended to do with Chibi Akumas, but that means a lot more looking up of commands within your manuals and things for the correct bytes to poke in. And this way, I'm just saying, well, whatever's currently there, just remember it and use that, whereas if I was putting in individual hexadecimal byte codes, it would save a little bit of memory, but it's much more of a pain. And we've got the definition for our sprite here. For the character, the characters drawn to the screen, the font, they use the same 16-byte definition as our main graphics, so we can use the same routine. We're then using our fade out routine here, which is a generic fade out, and we are changing the music to the introduction music here. And then we're going to show the animation list to the screen. Now let's have a look at that animation list. So this is the 4 animations you can see. They're just playing away over there at the moment. You can see those. That's what we're talking about here. So this is 4 different kinds of frame, and there are 2 frames of animation for each one. So you can see here, this is intro 1, and that's 1B. Here's 2, and here's 2B. And so these are the tile maps that we're showing to the screen. But the sequence and the positions of them are defined by the intro anim list here. So we've got an X and a Y coordinate and then a color number. So this is color 1. And then we're showing intro 1 followed by 1B. An X and a Y coordinate followed by color 0. Intro 3, 3B. I obviously got them in the wrong order when I was drawing them. And then here we go again, X and Y and a color. And intro 2 and 2B, and then 4 and 4B there. So you can see here there's 4 different ones. And there's coordinates and memory addresses that we need to work with. And we will see that reflected in the actual drawing code just here. So here we are, here we're loading our X and our Y position here, and then we're loading the address of our tile map here. We're then showing that tile map to the screen. The screen would currently be black, so we wouldn't be able to see this. We then fade in to the color specified, loaded into A there. We then delay for a while. We then show the next frame, so that's our second frame there. We then delay a little while longer, and then we fade out, and we repeat the entire procedure again, moving to the next definition there. So that routine here, it's not very long. You can see there's not so much of it. Here's all of it. That's the entire animation routine for showing the title screen. So yeah, nice and small, gets the job done there. And then what we're doing here is we are clearing the screen and delaying a while, and we're putting a 1 into the accumulator, and that means that the speech sample will play. The speech sample only plays after the introduction. It doesn't play if the game's ended and the introduction is not shown yet. So that's why we're using the accumulator there, because the speech only really makes sense if you've seen Operation Wolf and you've seen the introduction, because that's how Operation Wolf worked. It showed the animation, showed the title screen, and then it said Operation Wolf. Well, mine says Operation Suck. So that's what it does. Now, there's obviously some glitchy code going on there, because the stack, when the game ends, when the game over screen shows, doesn't reset back to the place it should. So as a quick workaround, I just reset the stack to the default empty position when the game starts. A bit of a cheat there, but it did work. And here we're just setting things up. Now, the 3D title screen is actually drawn in 2D mode. If I get the title screen up here, here's the title screen. That's the tiles. So this is the 3D title screen, but it's a 2D bitmap. It's not drawn with the 3D rendering routines. So we are setting 2D mode even if we're actually in 3D mode. We're then selecting which of the tile maps we want to use, either the 3D one or the 2D one. We're showing the tile map to the screen, doing the fade in, and then we're setting the palette to whatever the palette should be. Now maybe it should be the 3D colors or the 2D colors, but it will be set to whatever is appropriate there, and then we're running do set 3D as well there. Finally here, we're showing the high score in the corner of the screen. You can see that. You can see that just here. Here's that high score, and of course that is 3D as well, because the font routines are 3D. And then what we're doing here is we're checking to see if we want to play the speech. If we do, we pause for a while, and we play the speech sample with Chibi Wave. And as I say, if you want to know how the speech is done, the platform specific series covered Chibi Wave. It wasn't modified in any way for this tutorial, for this game. I just dropped it in and it worked just fine. And so here's our main loop. We're just waiting. After a while we'll show the introduction a second time. We're reading in from the keys and seeing if we need to change the 3D settings, because we can change the 3D settings on the title screen. If I press 3 here, there's the 2D version, and if I switch back to 3D and I can change the colors. So that's what that's doing there. Okay, so what we're going to do next is we're going to take a look at the palette routines and the 3D routines then. So here we go. So here is the set 2D 3D mode. This is to restore the previous 3D mode. So it's not changing the 3D mode, it's just restoring it. Now here is what we do when we're setting the 3D. This is resetting the self-modifying code to the settings that it used to have. So you can see we're loading from the backup and we're rewriting the show sprite R byte. Now that would have been set to a return if we've moved into 2D mode. And then we're resetting the 2D left section, and that will have been set to a jump relative in 2D mode. So these are now being restored to their proper code. Here's the change 3D routine, and this toggles between 3 different stereoscopic depths and 2D mode. So we're masking the bottom 2 bits to toggle between the 3, and if needed we're setting 2D mode. Now here is the 3D mode. We're basically just updating our palette here, and here's the 2D mode. Now that C9 there is a return, so we're putting that at the start of show sprite R to turn off the show sprite R routine. So here's the start of show sprite R, and we would just plonk a return there, turning it off basically. A nice self-modifying way of turning off that code. Now the other thing we do is we disable the mask on show sprite L. We write these bytes here, which are a jump relative by 4 bytes. Now we're basically putting that just here, so that would replace that and we would skip over those 4 RLCAs effectively down to here. That's what we're doing. So that's what those bytes do. Now when it comes to setting the palettes, we always use 4-byte definitions. So what we're doing here is we're selecting one of the palettes from the offset here. We are just calculating the offset there, and then we're going to transfer the 4 bytes to the graphics hardware here, and that will set the palette up. Now the palettes are defined in hardware numbers here, so they may look a little bit odd. So 5.4 for example is black, so that's an entirely blackout palette there, which is used for when you can't see anything, when things are being drawn without you seeing them. The 4 palettes for the 3D effect you can see here. The first one is the pseudo grayscale with the purple for the dark grey there, because unfortunately the CPC doesn't have three shades of grey, and then we've got the 3 options for the 3D glasses there. So those are the 4 3D palettes, but we also have the fade palettes. We've got the blue fades here, there's the fade out version, here's the fade in pink, here's the fade out pink. So there's 4 different palettes there for the fading effect, and we use those here. So here's do pal fade out Q here. This is the quick fade out, and it fades and then clears the screen. Here's the quick fade in, and it fades in, and then it sets the 3D mode back to whatever it was. And these are used for the gameplay, when the new level starts and when the level ends. These are used as a quick fade in and fade out. During the title screen, we have these versions here. Now we're loading in the pink and the blue palette fade definitions into D and HL here, and then what happens is when this runs, we check the accumulator and we switch to either the blue one if the accumulator's 1, or the pink one if the accumulator's 0, and then we use the set palette 4 to set the colors, and we repeat 4 times to give the fade effect with a little delay in between each one. And that's how we do the fading effect that you saw during the title screen, and the 4 colors in the 4 sections of the screen. And as I say, that's basically making it easier to define which ones of the palettes is used, because that first 3 bytes there, as I said before, is an X, a Y and a color number. That's how we do it. So that's the way that we're defining the palettes and how we switch them. Anyway, that's all we're covering today. This one was a little bit shorter. The last episode on the CPC we're going to do is going to be on the rest of the game code. Hopefully we'll be able to get through the rest of it in one go. Anyway, I hope you've enjoyed this. As I said, go to my website, get the source code and all that kind of thing, and get the game. And if you want to support my content, you want to see more and better games in the future, please consider buying my book. It would help me out. You can buy it from Amazon. It's called Learn Multi-Platform Assembly with GB Ackermers. It covers Z80, 6502, 68000, 86, and ARM. You can also become a Patreon, as you can see over there. The Patreon list scrolling away. Patrons get the content earlier than everyone else. I release them videos to the patrons usually about 2 months in advance. So if you want to see the latest stuff and you want to give feedback and suggestions, you can consider doing that. Anyway, I hope you've enjoyed this. Thanks for watching today, and goodbye.